Chromate salts contain the chromate anion, CrO42-. Dichromate salts contain the dichromate anion, CrO2O72-. They are oxoanions of chromium in the oxidation state +6. They are moderately strong oxidizing agents. In an aqueous solution, chromate and dichromate ions can be interconvertible. Chemical properties: potassium chromate, potassium dichromate. Chromates react with hydrogen peroxide, giving products in which peroxide, O22-, replaces one or more oxygen atoms. In acid solution, the unstable blue peroxo complex chromium oxide peroxide, CrO2, is formed. It is an uncharged covalent molecule which may be extracted into ether. Addition of pyridine results in the formation of the more stable complex CrO2py. Acid-based properties in aqueous solution, chromate and dichromate anions exist in a chemical equilibrium. 2CrO42- plus 2H plus Cr2O72- plus H2O. The predominance diagram shows that the position of the equilibrium depends on both pH and the analytical concentration of chromium. The chromate ion is the predominant species in alkaline solutions, but dichromate can become the predominant ion in acidic solutions. The change in color with pH from yellow to orange and the reversible nature of the equilibrium have been beautifully illustrated. Further condensation reactions can occur in strongly acidic solution with the formation of trichromates, Cr3O1O2-, and tetrachromates, Cr4O132-. All polyoxyanions of chromium have structures made up of tetrahedral CrO4 units, sharing corners. The chromate ion is a weak acid. HCrO4- CrO42- plus H+, pKa equals California. 5.9. The hydrogen chromate ion, HCrO4-, is also in equilibrium with the dichromate ion. 2HCrO4- Cr2O72- plus H2O. This equilibrium does not involve a change in hydrogen ion concentration, so should be independent of pH. The red line on the predominance diagram is not quite horizontal due to the simultaneous equilibrium with the chromate ion. The hydrogen chromate ion may be protonated, with the formation of molecular chromic acid, H2CrO4, but the pKa for the equilibrium H2CrO4, HCrO4- plus H+ is not well characterized. Reported values vary between about -0.8 to 1.6. The dichromate ion is a somewhat weaker base than the chromate ion. HCr2O7- Cr2O7 plus H+, pK equals 1.8. The pK value for this reaction shows that it can be ignored at pH greater than 4. Oxidation reduction properties. The chromate and dichromate ions are fairly strong oxidizing agents. Commonly 3 electrons are added to a chromium atom, reducing it to oxidation state +3. In acid solution, the aquated Cr3+ ion is produced. Cr2O72- plus 14H3O plus 6E- 2Cr3 plus 21H2O. In alkaline solution, chromium hydroxide is produced. The redox potential shows that chromates are weaker oxidizing agent in alkaline solution than in acid solution. CrO42- plus 4H2O plus 3E- Cr3 plus 5O- applications. Approximately 136 million kilograms of hexavalent chromium, mainly sodium dichromate, were produced in 1985. Chromates and dichromates are used in chrome plating to protect metals from corrosion and to improve paint adhesion. Chromate and dichromate salts of heavy metals, lanthanides and alkaline earth metals are only very slightly soluble in water and are thus used as pigments. The lead-containing pigment, chrome yellow, was used for a very long time before environmental regulations discouraged its use. When used as oxidizing agents or titrants in a redox chemical reaction, chromates and dichromates convert into trivalent chromium, Cr3+, salts of which typically have a distinctively different blue-green color. Natural occurrence and production. The primary chromium ore is the mixed metal oxide chromate, FeCr2O4, found as brittle metallic black crystals or granules. The rare mineral crocoite, PbCrO4, occurs as spectacular long red crystals. Rare potassium chromate minerals and related compounds are found in the Atacama Desert. Chromate ore is heated with a mixture of calcium carbonate and sodium carbonate in the presence of air. The chromium is oxidized to the hexavalent form, while the ion forms iron oxide, Fe2O3. 4FeCr2O4 plus 8 Na2CO3 plus 7O28 Na2 CrO4 plus 2 Fe2O3 plus 8 Colorado 2. The subsequent leaching at higher temperatures dissolves the chromates and leaves the insoluble iron oxide. Normally the chromate solution is further processed to make chromium metal, but a chromate salt may be obtained directly from the liquor. Safety. All hexavalent chromium compounds are toxic due to their oxidizing power. They may be carcinogenic, especially when airborne. The use of chromate compounds in manufactured goods is restricted in the EU by EU Parliament Directive on the Restriction of Hazardous Substances. Directive